Thank you, everybody, for being here. How many of you guys know about nanotechnology? You guys have heard about nano. You've been in the game for a while. I've been working in nanotechnology since 2000, 17 years worth, and we're still not necessarily seeing the commercial pickup that we thought we would, but one of the things that we strive at AxNano to do is try to leverage these nanotechnology into something that's actually usable, cost-effective, and actually can really provide support to the warfighter. So let's talk about the motivation. So does anybody know who Steve Wax is? He's now the CTO of DITRA. He was a program manager at DARPA. We were at a conference. It was a Nanomaterials for Defense conference, been run out of Wright Pat now for many, many years. And he got up in front of everybody and said, hey guys, we know we're going to get hit. We know we're going to get hit with a dirty bomb, you know, some sort of explosion, some sort of blast, and we really need something that's easy to deploy, lightweight, low cost, that we can get to the first responders, so we make sure we don't have a 9/11 scenario where everybody has all these problems with the dust and so forth and so on. So we got to looking at it, and we were working in the area of nanofibers for carbon fiber composites, and we weren't getting to the strength that we wanted to get with the carbon fibers, and as everybody knows in carbon fiber composites, it's all about strength. So we pivoted and we started looking into designing systems for filtration. We're in Greensboro, North Carolina. Purolator has a plant there. They do all their military aircraft filters there, so we got to talking to those folks about it. And then we got thinking about what Dr. Wax said, and also some other folks at DITRA, and we started into a design of experiments on, you know, is there a way for us to come up with a lightweight, low cost, something that we can get our forward acting folks into a place of safety in a very quick manner, and we started working on these designs. We mainly have been thinking about chem and bio. We haven't thought a lot about radio, but radio may come along for the ride because we have absorbent materials that we're going to talk about in these systems. So here's the magic. So if you guys have ever heard of electrospinning, so electrospinning's been around for a while. University of Akron is one of the world leaders in that space, but basically you take what's referred to as a spin dope. It has a charge on it. You have a plate that is basically the ground, and you can actually take a needle and squirt these fibers out, and it looks like, you guys remember silly string? It kind of looks like silly string, except for it's very, very small. So that, you know, you can see the scale here, that's 200 nanometers, so you're looking at about a 400 or 500 nanometer fiber. And the other thing to notice is, can everybody see all these features on here? Those are metal oxides. So those are other nanoparticles. So you have multiple nano domains here that you're working with. And the really interesting thing is we can mix and match and put all different types of metal oxides in these fibers, not only on the surface, but actually throughout the diameter. So these are known materials used in chem-bio warfare protection now. And the nice thing about it, and why everybody does nanotechnology, is the second bullet. It's a super high surface area. So if you think of your body, and I was thinking about this on the plane last night, if you think about your body as being in a micron domain, one of your single hairs would be in the nano domain. So think about that, how many hairs you can align in the diameter of your body. Millions, millions. So that gives you basically the potential to have a fairly thin filter media that could be very, very, very reactive. So we believe that we can do these. The electrospinning process is very good at doing unwoven mats. There's a manufacturer that makes equipment that does this, El Marco, they're out of Czechoslovakia. And also I have a grad student in the hood that can make these materials as well. And this adds a lot of functionality. So, you know, we've got some mock-ups. We are working with a textile manufacturer in the United States. They're based in North Carolina as well. They actually have the ability to 3D weave some new materials. Also, when you think about the structure of what you want to happen where on these materials and these masks and so forth, you know, where do I need it to breathe? Where do I need it to be insulative, where do I need it to be conductive, and we can do all that. So with that, throw out a challenge. Can anybody guess what airport I flew out of? No answers yet? So basically, you can always tell when someone's flying there in an airport, what are they going to buy? Because everything is tagged. So roll. So the idea is that we've got someone operating in forward area, they're covert, they need to carry something very lightweight, they're not in military uniform, they can be in civilian uniform, and how do we outfit them very quickly with a mass coverage system that basically protects them so they can get to safety. This was easier in the hotel room. All right, any questions? Right. Yeah, so the original design, we were looking into, we didn't have enough time. We actually put this together in about 2 weeks, these mock-ups. But the original design was to basically integrate a visor system into that. So some sort of a clear plastic system. And also, my wife works in dermatology. When I was showing all this to her the other night, she goes, wait a second, I can see skin. I said, yeah, hon, I know. We haven't got the visor in yet. So that we believe that's going to be a critical part of the design. But the key is, hey, I can pull it out of my pocket, unrip it, get it on, get the safety, decon, take what you wore, throw it away, and everybody's good to go, is the concept. We've got preliminary, we're working with Army Natick. We've got many samples in front of them now. We have not tested it with chem-bio simulants, but we have looked at antimicrobial behavior, and this has excellent antimicrobial behavior. So we're basically waiting on funding and path forward to work with Natick. But they have the samples, the material transfer agreements in place. I just got to identify the funds to get it through their testing, because simulant testing is not cheap. No more questions? All right, thank you very much for your attention. I'll be off to the side.